Hi, everyone. Good afternoon. My name is Megan Kreutzberg. I'm at the Institute for Natural Resources at Oregon State University. And I had a really great opportunity to work with this big list of authors you can see at the bottom of the slide, led by Brady Allred, to develop some guiding principles for using satellite-derived maps in rangeland management. So when we're talking about satellite-derived maps or remotely sensed maps, these use imagery from satellites or aerial photos. They're trained with plot data on ground, and then they go into a computer algorithm. And so the product that you're interacting with, like a vegetation cover data set, comes from a computer model. And as we know, the saying, all models are wrong, but some are useful, that really applies here. And we think that if you keep these guiding principles in mind, that will really maximize the usefulness of these data. So the purpose really is to advance the practice of using maps by offering these 4 guiding principles. First principle is use maps within a decision-making framework. Second one is use maps to better understand and embrace landscape variability. Third, keep error in perspective. And fourth, think critically about contradictions. And I'll go through each of these, kind of give you a whirlwind tour of each of these ones in the next couple minutes. So principle 1, use maps within a decision-making framework. And so this one, there's a lot of maps out there, and some of them have really cool, fancy web tools, and it's really tempting to want to just dive into the data. I do that all the time. But what we encourage folks to do is take a step back and really think about the utility of maps, how they fit in your decision-making framework, and how they will help you answer your management question. So if we think about the management application, remotely sensed maps are going to be really helpful in some stages. Things like inventory and assessment, strategy and prioritization, monitoring, they could be pretty helpful. Things like setting goals and objectives, figuring out details of implementation, maybe not as much. So use maps where they're helpful and don't use them where they're not. Also, the utility of maps often increases when you get to questions at broader spatial scales. So that's principle 1. Principle 2 is use maps to understand and embrace landscape variability. This has come up a couple of times in previous talks. So maps really they provide really rich information across big landscapes that can help us move beyond some of the simplifications like averages or representative sites. Not that those don't have their place and are very helpful for certain questions, but maps allow us to zoom out. So this example here shows 2 pastures, one on the left and one on the right, have basically the same average value for annual herbaceous cover. But as you can see from the maps themselves, and as well as the pie charts, they're very different in what they really look like on the ground. That heterogeneity is really different. So something, a sort of simple representation of that pasture 1 on the left may work pretty well. Pasture 2 on the right is just really variable. So maps can really help us kind of lean into that variability. Principle 3 is keep error in perspective. So, error is a tough one, and sometimes maps just have too much error to be useful. But we really encourage users to think about what level of error is acceptable, what level of accuracy do I really need for my management question. And if you think of kind of a continuum of questions, at the top, things like what is the distribution of threats across a big landscape? Where are the areas of greatest management need? These are broad scale general questions where local accuracies may be less critical, and maps really probably add a lot of value. Then when you get sort of down towards the bottom of this list, these get really fine scale, more specific. Things like where should I place treatments on the landscape? How effective have my treatments been in the past in changing vegetation condition, for instance? Local accuracy is probably going to be really critical there. And so maps may be less useful, maybe just certain maps will sort of have the characteristics you need and the level of accuracy and precision. But there's this continuum. And then the last one, principle 4, think critically about contradictions. This one I think is the toughest one. Maps can contradict each other. They can contradict data sources. They can contradict, knowledge we have about the landscape. So, you can use various ways to evaluate these maps: expert opinion, imagery, plot data, management and disturbance boundaries overlaid on maps. But at the end of the day, this is a tough one. And really, it's about sort of thinking broadly and critically, questioning the maps, also questioning the plot data, and questioning sort of your assumptions about the landscape. So just to recap these 4 guiding principles, I'll put these up on this last slide and be looking out for the manuscript coming out in Rangelands later this year. Thank you for your attention.